Excellent. Hello, everybody. Thank you. Excellent. Vodka? Cool.
You find it out after the talk.
Oh, we did. Okay, lovely to meet you all. Thank you for inviting me. And thank you for inventing Keynote. Is that right? The little, oh my God. Oh, I filled my bag to take home like 5 kilos of Keynote. They won't make it to Christmas. Okay, so I'm Director of Developer Relations. Oh, I've lost weight. Thank you, Ozempic. Thank you. I have been working in IT for 28 years, something like that. And I began work in government. I worked in local government offices in London and then moved into a regulator. So I know what you mean about regulations. And it was at a time when nobody really knew what a website was. I remember implementing email for people. It's hilarious. People were talking about paperless offices. About 20 years after that, I moved into digital and data at a large company based out of the UK called Associated British Foods. And they had about 20, 25 websites, all global websites. And each one, of course, had its own CMS and a different version of a different hosting system. So that was fun. So that's when I really learned about why monitoring things really mattered. Then fast forward another 10 years, 5 years. My maths is terrible. It's not good for being in a bank, is it? I'm not good at maths. And I joined Imply. Now, Imply, this is when I learned about Kafka. Any Kafka fans? Good, good. Druid, Flink, Spark, all of that was kind of new to me. I was used to like IIS and Oracle 7, and then suddenly had to learn about Spark streaming jobs. And I started working with some really big companies who were trying to implement sub-second analytics databases, Apache Druid being one of them. And I got my hands dirty being an actual contributor to the Apache Druid community. Apache, excellent Apache. Oh, and also CNCF. I can't forget CNCF. So we've been around for about 10 years now, and the focus has always been on analytics. So my background has been a little bit trying to keep websites running, a little bit enterprise architecture, and now a little bit data. So I've lived on both sides, if you like. I've done the desk job, and I've done selling you things. So when I was asked by my colleagues at the back there to come and talk to you about observability, I thought, I'm not just going to come here and try and sell you everything that Imply does. So what can I do that will be a little bit more informative? So you can tell me afterwards how successful I've been, okay? You can be honest. You're all Dutch, so I know you're going to be honest. So we had some reports published earlier this year, and they were all with C-level executives about what observability is like now. So the 3 things that I found out from this report, first of all, lots and lots and lots of tools, so tool sprawl. Then we have things being really expensive, and then we have, well, I was at Splunk conference earlier this year, and someone came up to me in the middle of a migration and said that they'd just taken all their dashboards from Splunk users, they'd just taken all their dashboards from Splunk and moved them into another tool, and they were all different, and they didn't know why. All the searches seemed to be the same here, the data seemed to be the same here, over here in this other tool, another tool, completely different. So migrations are really, really difficult between these tools. So you kind of get stuck. So I thought I would present to you my idea of what I think might be going on here. And I think it comes down to architectural principles. So I'm going to sound like a politician. It's principles. So I'm going to introduce to you some architectural principles that really made a massive difference to me as I was working in the data space. And these aren't principles that I've made up, right? These are principles from a framework called TOGAF, which is like a framework for enterprise architects. And this is 4 of several architectural principles that there are in that framework. It's actually quite a good framework, so if you want to go and have a look at principles for architectural design, go and have a look at TOGAF. So these are principles that are meant to help architects to check whether what they've designed actually makes sense, okay? And it covers several different domains, so not just technology, but also business domains and data domains. So again, these are 25-year-old ideas. This is nothing new, okay? So I want to give you some examples, therefore, of some places where these principles have worked really well. And you've all been in observability for a while, so you'll have heard this, but perhaps explained in a different way, okay? So Apache Kafka is a fantastic example of data being a shared asset. So it is not tied to a particular database system or a particular producer or a particular user interface. The data flows in and you can use it anywhere. You can fan it out to lots of different end systems. You can use it for machine learning. You can use it for real-time alerting through Spark streaming or something else. It's completely independent of the computer package that you've purchased. Lots of teams using the same data to do lots of different things. Data really is a shared asset. What you don't have is lots and lots of duplicated data pipelines everywhere just because it happens to be called a metric now, as opposed to it being a log. Kafka doesn't care. Then let's turn to ease of use. Some of you may be the same generation as me and remember when you bought this little cardboard box with probably about 30 CDs in it. And in that cardboard box, you would have your database and you would have your reporting tool and probably something to build the UI with. And you bought that box and that's what you got. This, in the 90s, was quite novel. That I could install something called Crystal Report. Anybody remember Crystal Reports? Crystal Reports, and that would plug into Oracle. Did it have SQL Server then? I can't remember. But the UI was different to the database. And we then ended up when this kind of like more modern data stack, where we have our good friends, Microsoft, Google, and Amazon, and others, where we have the best of breed products/projects at different layers of the architecture. And I can swap them around. This is technological independence, right? I can swap them around, and what I get as an end user is exactly what I need for the job I'm going to do. So if I am working in data science, I've got to use Spark on top of my data lake. I just pick the tool that I think is correct. So in observability, yes, it's one thing. We can argue about SQL, but it's one thing that you have PromQL, LogQL, SPL. Let's not have that argument. But it's also that you are forced to use that language with that specific tool for that specific backend. That's what frustrates me. So is this changing? Yes, of course, Splunk and Elastic and Datadog, they're all investing heavily in their user interface to make it easier for everybody to just get on with and use their tools. That makes commercial sense, right? But please, vendors, can we stop creating a new language with a new UI just because we feel like it? Just stop doing it. There was a gentleman called Jacek who spoke at the CNCF KubeCon in London this year. His video is way better than I can ever talk about languages, and I do recommend watching that. It's a really good talk. A bit of a summary of where we are and what we might do in the future. Okay, then the final two principles are technology independence and interoperability. And for that, I want to talk about the big yellow elephant that was Apache Hadoop. So the first time that I came across Apache Hadoop, I was analyzing the quality of beef and determining what the key factors on whether the beef was good or not was, because I was working for a company that did cattle feed. And I had to use that. That was it. Everything was glued into and part of the big yellow elephant. Fast forward 2 years. Fast forward 2 years, and then we have separate projects and solutions for the storage, different table formats, Iceberg. Then we have different query and search engines sitting on top of our data. So before that, you had a closed stack. And after that, lots of vendors, each of them doing what they do really well in this kind of more open technology. We wouldn't have Iceberg if we were all still stuck with the big yellow elephant. I had exactly the same situation in BI, and we wouldn't be where we are now with data science and with me arguing for hours about ChatGPT, with ChatGPT, I should say, if we hadn't had this opening up. So in observability, we have to be able to pick the right tool for the job. And we have to be able to pick the right solution, scale the right portion of it, and embed resilience where it's necessary, using the tools we actually want to use. These are not complicated things. So, Charity Majors, woo charity, said observability is about understanding systems from the outside in. It's not about the tool you use, but the questions that you ask. The CNCF is all about interoperability, about opening up the stack. It's saying that observability protocols and formats must be open. Is all this really, really sensible, obvious stuff? Good. So, decoupling is how we open up the stack. It's how we as SREs get more choice. It's about how we get the scale, the resilience, the performance, all these conversations we're having about whether or not we use agentic AI, we're going to have scale. So, let's have a look at a bit of a model for how I say we should think about what we do with architectures and observability. And for that, I'm going to have 3 boxes. I'm an ex-enterprise architect. I have to have boxes. So 3 boxes: telemetry collection, information management, and insight generation. And at the bottom here, I have a little bit of a value statement about what I think we should have in our heads, just 2 words, when it comes to each of these boxes of tools. So in this box here, we have anything to do with collection. So it's our agents, our exporters, etc. And I'm just saying, let's just collect it openly. That's it. Second one, information management. So this is where we will store the data, whether it's structured or unstructured. I don't care if it's a potato or a metric or a cheese board or a stroopwafel, that is going to be stored here. And all I'm going to say is store that responsibly. Then the third box is for anything that is user-facing, so this is the UI. Now, this is a bit oversimplified. I appreciate that. So with telemetry collection, we might actually, enterprise architects and solution architects in the room, split this out into production, storage, and processing. With insight generation, you might split that into modeling and to AI, BI, and immediate intelligence. So I appreciate it might be a bit too simple for some of us. But these are the equivalents to BI. In BI, I would have said this was ingestion, that this was storage, and that was analytics. So those are the 2 worlds that I'm trying to bring together, okay? So what goes into each box? Well, everyone knows that the left-hand box is going to be OpenTelemetry. Other projects are available. But OpenTelemetry, everybody loves OpenTelemetry, Grafana, New Relic, everybody, okay? So we're just reinforcing now that primary principle that data is everyone's asset. It's a shared asset. OpenTelemetry, awesome. Instrument once, send it everywhere. That is really collect openly in practice. And if you are using OpenTelemetry, being a community person, I did speak to someone at the last SRE day in London, which was cool, who was from the OpenTelemetry community. And if you are using it, please contribute. Please find a way, even if what you do is you change the spelling of a word in the docs, that is fine. Please contribute. So we have different tools over here on the left-hand side. We're getting here is a bit of a Kafka for observability. Then over on the right-hand side, we have Grafana, Kibana. I love Superset, so I'm going to mention Superset over on the right-hand side. So this is not entirely brilliant quite yet, but we are getting close to, this is the UI that I want. I want to press connect, and I am done. That's what I want to be able to do. So what goes in the middle box? I wonder what that could be. I must have to get my logo T-shirt out. So what we want in the middle box is something interoperable, where we don't have to change everything, something that is about ease of use, that makes it easier for people to do their work every day, and something that makes data a shared asset that everybody can get access to open up more data for longer. So, surprise, this is what Imply is doing. This is what we're trying to do, is that central box. So we've created something called Lumi, and it is a warehouse for observability data. So it is decoupled. You don't have to pick a particular UI to use with Lumi. You don't have to pick a particular upstream tool to work with Lumi. So it is a storage and compute layer built from the ground up for scale and for concurrency. That's what Imply did with analytics. So it offers storage for the telemetry, and it has a special compute engine for the insight side. And it is all about upholding this principle of interoperability. So it acts more like a jigsaw piece that works alongside your existing tools, rather than you saying, okay, you have to use this particular collector with it. And it comes from a background, I appreciate that many of you won't know about Imply. So Imply has been working at like the petabyte scale, lots of resilience, lots of concurrent users in the data analytics space for a while. And this is where we are turning our focus to, which is observability. So do we have Splunk users in the room? This hopefully will make sense to you. So we have Lumi over here on the right-hand side. It appears to be, to Splunk forwarders, just an indexer. So I can use HEC, S2S, and S3, no worries. When it comes to the insight generation, it just appears to be a remote search head. So you continue using SPL, you don't have to learn a new language. So we are trying to not mix too many things together. We want something very specific that just fits into the Splunk ecosystem. So you can just keep doing what you're doing. Grafana users, it appears to be low-key, right? Maybe I want to throw in some OpenTelemetry data. So now, for example, I can collect with a Splunk forwarder and then search it using LogQL with Grafana. Or maybe I want to be able to search it using SQL with Tableau. Great, we have a JDBC UI. If you want to use Claude Desktop, we have an MCP server. So the point of this, again, is interoperability. It's like an interoperability layer that protecting your existing workflows, that fits into your existing architecture, and where I can change little bits of it. Obviously, we want you to stay with imply, but you could change the individual components. It's opening up the environment. It's giving you more scale when what you want to do is collect VPC peering logs. Last month, we added ingestion from S3 buckets, so it kind of watches a bucket and then just pulls the data in. And we've got storage tiering coming, so Splunk users, again, if you know DDAA and Smart Store, it's similar to that. So again, this is about coexistence. It's not about replacing. I mentioned compute speed. So because of what we're doing behind the scenes in terms of the compression and the way that we actually index and pattern match data, the compression is ridiculous. It is, compared to our previous tool, the name of which I won't tell you, is about 3 times smaller. So it's a really high compression. So I can keep 30 days instead of 10 days worth of data. I can do things like pull in my VPC flow logs or my CrowdTrail logs, because better compression means lower cost. So what about the performance? These are DevRel figures, by the way, not marketing figures. I know that sounds weird, but I quite like maths. So we have very, very much faster performance on searches. Now, this is not because what Lumi is doing is taking the raw data and creating a table from it. That's not what it's doing. It's using quite a new computer science technique to find patterns in the logs entries, in the raw data, and then create a structure out of it which can reconstitute to raw. But because it's acting on compressed data, you get ridiculously faster queries. And they really are really, really fast. So if I've got dashboards that currently, I was talking to someone at Splunk, they'd had to turn the dashboards off because it kept killing the cluster anytime anybody searched anything. If you have dashboards that are a little bit slow, this is a great storage layer for that, because I can just get that increased performance just on that bit of data. Again, this is the sub-second analytics thing creeping in. So, AI-based slide. Thank you. Excellent, thank you, AI. So what is Lumi about? It is about optimization of the data. It's about protecting the existing workflows. And it's about being able to do more with the tooling you've already got. If you want to read more about it, there is a blog on imply.io. We've got some little guides, including like connecting with Cribble, if you're Cribble users, et cetera, et cetera. And you're all technical, so I know what you'd rather do actually is read the docs. So you can go and read the docs written by a very nice friend of mine called Charles Smith, who's brilliant, very well written docs, unlike other docs I can mention. So that's what it is that we're trying to do. What we're trying to do is apply the principles of observability that have been around for 25 years. We're trying to enable people to operate as is, to do more with what they have, and to be able to access and retain way more data than they currently do, but to do that very, very quickly, just because we're focusing on the data layer. Oh, we've done really well with time. If you want to come and have a look, where's Ravin? Out there somewhere. Well, our stand is out there. Come and have a look at the demo. Thank you. That wasn't too salesy. Was that okay? Good, good, excellent. Good, good. Thank you.